My name is Todd Harrop, and I'm a doctoral candidate at the Hochschule für Musik und Theater, Hamburg, Academy for Music and Theater, in the Center for Microtonal Music and Multimedia. My dissertation is on musical scales without octaves. This interval is taken for granted, but there are cases where it is not present and might even be replaced. My paper for SMC explores some aspects of this, and during my talk I will dip into my own compositions to draw up examples. I find this a challenging problem. If the octave is missing, how does one invert chords or transpose motifs? Here in Hamburg, we're quite interested in replacing the octave with the perfect 12th, or tritive, as it's known in Bolin-Pierce music theory, by using a frequency ratio of 3/1 instead of 2/1. Or what about the 3/2 ratio? This is the perfect fifth. Are there scales which favor this interval over the octave? One could look at traditional music of Georgia, for example, or perhaps northern Arctic Canada. But we won't, because that is ethnomusicology, and that is way beyond the scope of my short paper. Instead, I will give a rundown of how I used simple computation to choose several microtonal scales, which could play one basic chord. Then I will show 3 methods for how a composer could transfer from one microtonal scale to another. Using Wendy Carlos's method on a 6/7/9 septimal minor triad, we get a plot of accuracy across non-integer divisions of the octave. This is the white table in the lower right. The peaks of accuracy for expressing this chord happen to be at 8, 13, 16, and 21 integer divisions of the perfect fifth. I reject 16 because it's redundant, 8 times 2, and though 21 is perfect, it's actually a 6th tone scale, which means it has an octave, and in my research I'm not looking for octaves in my research in music. 18 is not bad, it's a little lower than the others, but I will take it. If I had wanted octave-based scales, I would have compared integer divisions of the octave and come up with 36, the 6th tone scale, 41, 22, or 31 tones per octave. In fact, 31 per octave and 18 per fifth are nearly identical, as if the 18-tone scale had been stretched by 1/10 of a semitone. My piece, Apollo, for percussion and computer, which, by the way, was premiered down the hall in May, uses chords which are possible with 18 tones per fifth, but maybe not 31 per octave. For example, a perfect fifth major 7th triad from harmonics 18, 27, and 34, or a minor 6th neutral 9th triad from subharmonics 11, 7, 5. We have examples here on the bottom. With computation, we can quickly compare all combinations of pitch sets in 2 scales and then sort them into shared and unique chord lists. I have an audio example. Let's see, I will try this. Okay, it's very, very, very subtle. 2 things I just want to say. What I hear is a slight wavering in the decay part of the piano tone. The wavering could be, slightly out of tune, or this could be a favorable quality of the tone. In the 31 tones per octave chords, and in the next ones I hear a little more stability. The second thing I want to point out is that last night I'm sure I heard more of a difference when I was making this audio file, and then when I exported and listened back this morning, I need to check that. It is rather subtle. You might recognize the 18 per fifth and 8 per fifth scales as Carlos's alpha prime and Gary Morrison's 88C. Of the 4,000 scales in the Scala archive, there are 8 which are variations on 88C, and all but one of them can express this 6-7-9 septimal minor triad nicely. There are also 8 scales similar to alpha prime. However, my own version is best for 6-7-9. I also found 6 scales close to the 13 per fifth scale, and 2 of them could play a 6-7-9 triad, though out of tune. In sum, I took 3 scales for my research of 8, 13, and 18 steps per fifth, then tweaked them slightly to tune the thirds better by sacrificing the perfect fifth a tiny bit. Now, how does one transfer from one scale to another if I want to use them all in a composition? I can propose 3 ways. This is the main part of my paper today. Communic, interharmonic, and dynacyclic. I'm not trying to coin these terms, but they seemed appropriate for encapsulating each description, which I will now do. Communic is using pitches in common, or almost so, between scales. Imagine a quarter tone scale and a sixth tone scale. How many pitches do they have per octave? How many pitches do they share? 12. And any of them can be used as pivot tones or chords to move from quarter tone to sixth tone tonality. My piece, Bird of Janos for solo clarinet, is written in 2 microtonal scales, Carlos Alpha and Bolin Pierce here, neither of which has an octave, the closest interval being a sixth tone too narrow, 1170 cents instead of 1200. But the closest pitches above and below this quasi-octave across both scales differ by only 10 cents. They don't make perfect unisons, but they are passable as melodic pivot tones. The common tones between our 3 scales, 8, 13, 18 per perfect fifth, are of course the septimal thirds, perfect fifth, and it turns out there's a bump of, this is in the white, I have a C and then a D sharp, which is the minor third, E and G. Right, 8, 13, and 18. But another common tone shows up, which I did not know about, a major seventh, sixth tone sharp. As a just interval, this could be a 27/14 ratio, or 25/13, if you want 7 limit or 13 limit harmony. Another candidate for pivot chord would be at the bottom, neutral third, neutral seventh, between the 18 and 8 tone scales. I have an audio example. We just go left to right, and then the next system, left to right, left to right. Middle. Bottom. And the last. I composed a little bit. I didn't just give you the chords, the exact notes that you see, because they would sound the same, but I played with them a little bit, improvising some melody around these notes that you see on the screen. This approach can be eyeballed and done without a computer, But the next two methods require A, computation to be fast and accurate, and B, a synthesis program to dynamically change tuning and, if desired, matching spectra. Here we go. Number 2, interharmonic can be considered the opposite from communic by using pitches unique to each scale for building harmonies not possible in one or the other. For example, neither a whole tone scale nor a diminished seventh chord can play a 3-note semitone cluster, if you imagine this on a piano or in your instrument. But if they overlap, then yes, it is possible. Looking at our 3 non-octave scales, 8 and 13 per fifth, together can form an equal-tempered major seventh chord on the right, or a just minor triad of 16, 19, 24. None of these minor and major thirds or the major seventh are possible in either scale alone. In fact, these 2 joint chords are nearly perfect. No doubt others are possible to use as bridges. I've worked these out by hand, but there are simply too many note combinations and too much chance for human error, not to mention tedium. This is where some computer coding would be beneficial for pre-compositional work. The fruit of this labor would be a palette of unusual sound marks to harmonically signal a change of section, for example. Think of it as a dovetail of one scale interlocking with the other. And now, dynacyclic, the third method. This is my fanciful term, dynacyclic, but this idea stems from Milne, Cetheris, and Plamondon, as well as Wolff, who was himself inspired by Irv Wilson's moment of symmetry, of which I only have time to describe one aspect, generator and period. Think of them as fifth and octave. We can fill out a 12-note chromatic scale with a sequence of equal-tempered fifths transposed down into an octave when necessary. We can also fill out a 43 or 55 tone scale with perfect fifths that are a hair less or more than 698 cents instead of exactly 700. Wilson seems to have been the first to generalize this to interval pairs other than fifth and octave. And instead of fifth comma or sixth comma mean tone organs, we can use computers to slide between scales by altering the sizes of generator and period in real time. I want to show you in Max Patch. Yeah, remote control. As a dynamic method for transferring from one non-octave scale to another, I made a circle of a circle of septimal thirds and reduced them to within a perfect fifth instead of a circle of fifths within an octave. For example, to fold and here's my circle of thirds. Think of it as a clock with perfect fifth at the top, and you can see on the right 7/6 is a minor septimal third and the other one is major. So this tick mark, which just appeared, is 1/3. If I do another, it will be across and a little bit over. You see that? And now I'm going to just fill in the circle with 17 of these, including the unison. That gives me an equidistant scale, also notated below. This is an 18-tone scale. Now, if I change the size of my generator just slightly, 5 of these notes will collapse onto another 5, and we will reduce the scale like this. Now we have 13, although we have 18, so there are some unisons, and I can do it again. And now we have an 8-tone scale, equidistant, with 5 pairs of unisons, that is 10 notes, are on top of each other. And of course, I will just go back and quickly finish my paper. I have an audio example. I will play this. I hope I have time. This is the 18-tone scale, and now it is going to morph. Now I hear some unisons. We'll morph again. Okay. Thank you, thank you. So I think I heard some notes that are repeated 3 times, or played 3 times, and that is definitely in the end where 10 of those notes have collapsed together. So to just finish off, this dynamic approach is only possible with a synthesis program. For example, I'm using Max MSP. Bridge sonorities or joint chords are best found by brute force computation. I used MATLAB. You can use JavaScript or whatever. And common pivot tones can be worked out by hand simply by writing down 2 or more scales and noting similarities. These devices are not limited to a 6-7-9 chord, of course, and I've only just begun these experiments in my own compositional work. So today we began with a search for non-octave scales which could express the same chord. They were found by plotting accuracy across non-integer scale steps, and I mean divisions of the octave. Then we looked at 3 methods for transferring between scales: communic, interharmonic, dynacyclic. And I hope that my humble musical examples have helped to clarify these concepts and perhaps motivate you to consider your own harmonic explorations. Thank you.
Thank you very much, Todd.
Thank you.
Are there any questions? Are there any remarks? Yes, Georg.
Very nice presentation, Todd. I have a question. You were using the term morphing, which is, I think, very appropriate. Before you actually applied it to dynacyclic, I actually thought maybe if we wanted to use the terms morphing and crossfading, interharmonic would be like crossfade, and communic would be like morphing. And I didn't know what term to apply to the last category, but obviously you have a different approach to that.
I mentioned some other researchers at the beginning of that dynacyclic section. Yeah, that's a term I used instead of, for example, Wolff's term. Daniel Wolff says transitional fifth squashing, because he described in Clarence Barlow's ratio proceedings. Wolff has an article, and I think this is what really inspired me for this, because he used a perfect fifth, but with a quite wide stretch from 720 cents to 680. And his table, I don't have it ready to show you, but his table had this similar idea where scales would collapse and split apart. So his term makes reference to the interval of the fifth, transitional fifth squashing, and I wanted something more general. Sethris and the others say dynamic tuning, but that also includes spectra and changing the partials. What you said about crossfading, exactly. They overlap, or that is a possibility. And if they overlap for the whole piece, that's polymicrotonality. So there are many terms, but morphing with the first one, with common tones or unions and intersections or morphing. But morphing is change. Actually, I really need to mention transferring. That's the term that Ivor Darig put out. And I'm sorry, I had a nice quote, but it's in the paper, which you will see in the Proceedings, where he says, let's not use modulate. That seems obvious, but it's loaded with tonality baggage. And so it was his idea to say transfer, as if from one train to another train.